Okay, so welcome to today's lesson, where we'll be looking at naming some of these simple compounds and also doing the opposite. Okay, when you're given a name, we'll learn how we can find the what, the chemical formula of a what, of a compound. Okay, so when it comes to naming simple compounds, okay, there are two main types of compounds. Before we even name anything here, I think I need to give you this insight. Okay, so there are two main types of simple compounds. Okay, so we are naming these simple compounds. Okay, so we have two types of them. So the first one is what we call as the covalent. Okay, the covalent compounds. I know you are familiar with this word. Okay, so this covalent compound, it means it contains two nonmetals that have been joined together, right? Okay, so for example, carbon dioxide, even water, we know that we have covalent bonds in these compounds, so they are called covalent compounds. Okay, and then the other types of compounds are what we call as ionic. So these ionic compounds are what we are going to focus on today. Okay, we are very much going to focus on naming these ionic compounds. Okay, so these ionic compounds come in two forms. Okay, there is one. Okay, let me say first of all, we know that an ionic compound consists of a what? A metal plus a non-metal, right? Okay. So this non-metal part here, okay, this non-metal part here, it can be one, it can be a single non-metal, okay? Marvelous, you are writing on my screen. I don't know what's happening, sir. Okay, so we have these metals, okay? In ionic compounds, we have a metal that is combining with a non-metal, okay? So that non-metal part of this covalent bond, it can be a single compound, okay? Or what we call as grouped ions or radicals, okay? Let me say radicals here. So these radicals are just grouped ions, okay? So it's a group of compounds and then it has a charge. So it's called the what? A radical. So these ionic compounds, you can have one in which you have a metal reacting with a single non-metal, okay? For example, in the compound sodium chloride, okay? In this compound sodium chloride, okay, we have this sodium here, which is a metal, and then we have the chlorine there, which is a what? A non-metal. Okay, so this is the first type, where you have a metal combined with a single non-metal. And then in the other types, under these ionic compounds, you have a metal combining with a radical, okay? So for example, if you get potassium permanganate, so potassium permanganate has this formula here, okay? So this potassium permanganate has one, the metal, which is this potassium represented by a K, okay? And then this whole thing here, okay, it's a radical or it's a grouped ion, okay? So this is a radical which is called as permanganate, okay? So those are the two types of ionic compounds that you are going to find, okay? Right, so when you're naming these compounds, your goal should be balancing the charge of the compound that you have, okay? So you can see that, for example, in this sodium chloride, we know that this sodium here has a positive charge. And then this chloride here, we know it has a minus charge. So when this combine with this guy, they form a what? A zero charge. So this here should be your main goal whenever you're naming this compound, okay? Or when you're drawing up the chemical formula, okay, for these compounds. You have to make sure that the charge of that compound that you have combined together is zero. Okay, what if we come and look at this potassium permanganate, this guy here, okay? So you will notice that this potassium here has a +1 charge because it's in group 1 on the periodic table, right? And then this radical here, I'll share a table with you guys for these radicals. There are a lot, okay? But this radical here, that is known as the manganate, okay? It has a -1 charge. So this -1 charge on this whole compound will combine with this positive charge to form a 0 charge overall of this whole compound, right? Okay, so that should be your goal when you are writing these chemical formulas and even the names, as you will see when we start answering the questions. Okay, so this is just a bit for your understanding of whatever we are going to be doing. So now let's try to go to the compounds and then we try to name them, okay? So we are dealing with ionic compounds today, and then the other day we'll name the covalent ones. Okay, so here they're saying, name the compounds in parts I to 4 and write the formulas for the compounds in part 5 to 8 there. Okay, so we have to write the chemical formulas for these, and then we have to write the names for these. Okay, so the first thing is to identify the compounds that are in that chemical formula that you've been given here. Okay, so the first one there, we've been given this guy here. We've been given NaBr. Okay, so we have to identify the elements that are there. So first of all, this guy here, we notice that it's a metal because that's sodium. So it means you have to familiarize yourself with the periodic table, okay? Of which that's what you were doing at grade 12. You can't tell me you don't know the periodic table at this level, okay? So this guy here is sodium, okay? And then this guy here, the Br, represents what? Bromine, okay? So when this sodium and this bromine combine, okay, they will form an ionic compound. Okay, so how can you name that ionic compound? You just write the first name of this metal. You're going to say sodium, sodium here, okay? And then this is bromine, okay? But since it's at the end of this compound here, okay, we are going to say bro, okay? Instead of bromine, we are going to end in IDE. Okay, so you always end with bromide, IDE. So this bromine here becomes what we call as a bromide. So the name of this chemical formula here will just be what? Sodium bromide. Okay, so the non-metal at the end there, okay, most of the times it ends with IDE. Okay, IDE. So this is sodium bromide. So anyone who has a question on how we are able to name this compound? Okay.
My question is it that every time, for example, this bromine, you have changed to bromide. So is it specifically this or the other metal, other compounds that will also change ID equals?
Yes, there are a lot of compounds, and you are going to see them. So even the second example here that I'm going to show you, it also has to end with IDE. So as long as you have, in the first place, you have a metal here, okay? And then you are combining this metal with a single non-metal here, okay? A single non-metal there. Okay, then you are going to say the name of this compound will just be the name of the metal, and then whatever non-metal that you have here, just make it end in IDE. Okay, so there's like a systematic way of naming the compounds. Okay, so now let's look at the other one there. Where is it? So the other one is RB2 and then O there. Okay, RB2 and then O. Okay, so R B, and then I have a 2 there, and then what? O. So why do we have a 2 in this chemical formula there? Okay, is to balance the charge. Remember I said the charges should always be balanced, right? Okay. This guy here, the RB, is what we call as rubidium. Okay, rubidium is found in group 1. So it has a charge of what? +1. And then this O, we all know it's what? Oxygen. So when you get the ion of oxygen, it will have a minus charge, a -2 charge like this. Okay. So when you combine this oxygen and this rubidium, make sure that the chemical formula gives you a charge of 0. Okay. So we see there that when we add that positive charge, this one here, and we add it to the minus charge, we'll get -1. So what do we do to eliminate this -1 here? We'll make sure that we have 2 of these rubidiums. Okay. So we have 2 of these rubidiums for 1 oxygen like that. Okay, so if we have 2 of these, it means the charges will cancel out. So how do we name this? The same way we named the previous compound. Okay, we are going to get the name of this metal because this rubidium is a metal. And then this guy here is a non-metal. Oxygen is a non-metal. So we are going to say rubidium. Okay, we are going to say rubidium. Okay, and then this is oxygen. So we're going to write ox, okay, side like this. Okay, so you see that this oxygen has changed to oxide because it's at the end here and it's a what? It's a non-metal. So the name of this compound there will be rubidium oxide. Okay, all right, I hope you guys are getting it. Okay, let's look at another example. So from the questions, what do we have? We have CAS, okay, and then there we have ALI3. Okay, so let's name this one here. So we have CA and then S. Okay, so the system is the same. We're going to get the name of this metal, okay, and then to the name of this non-metal, we're going to add IDE. Okay, so this is what? What is Ca? It's calcium from the what? The periodic table. So this is calcium, okay, and then this is S is sulfur according to the periodic. Do I have the periodic table here? Okay, so this S here is just sulfur. So to that sulfur, we're going to make sure that that sulfur just changed to sulfide. So this sulfur will be sulfur and then IDE. Okay, so this, the name of this is just calcium sulfide. Okay, I hope it's making sense. And then the other one that we had, okay, was AL and then I3. Okay, so I'd like to explain why we have the 3 here. It's because we are balancing the charge. Okay, for this compound, the calcium was +2 as its charge when it becomes an ion, even this sulfur has a -2. So they cancel out. But when you come here, this aluminium here, the Al, it has a +3 charge when it's ionic. And then this guy here, the iodine, it has a -1. So what do we do in order to make sure that the charges cancel? We add the 3 on this iodine. Okay, so no wonder we're seeing these 3. All right, so now let's name this guy. So it's the same thing. We're going to get the name of this metal, okay? And then to the name of this non-metal, we are going to add IDE. Okay, so we're going to say this, the name is just aluminium, okay, aluminium. And then this is iodine, okay? This is iodine, like this, iodine. Okay, so this iodine is going to change to iodide. So it will be aluminium iodide, okay? And then we put diet class 2. So this will be the name of this compound here. It will be aluminium iodide, okay? Okay, so any questions there, guys? You are free to ask. Are we moving together?
Kama mfumo wa repeat pale kupatia na balance hizo. ngano kwashwa
Here on the balancing of the charges. Hello, the one who's asking, you're asking on the balancing of the charges here.
Yeah, balance of the charges, how you balance the charges, kwashwa plus 3, positive 3, negative 1, even most are that's fully add then
Okay, so I was just explaining why we have I3 there. Okay, it's just given like that in the formula. When you look at here, it's given like that in the formula. So we have AL and then I3. So I was explaining why we have these three here. We have these three here in order to balance the charge of this overall compound here so that it can be 0. Okay, so the charge of aluminium is +3. And then the charge of this iodine is what? Iodide, I mean, it's -1. So what do? Okay, we make sure that we have 3 of these iodides. So we have plus another -1, plus another -1, so that even for this iodide, we have a -3, and then this -3 here is going to cancel out with this +3 to make the charge of this whole thing to be what? To be 0. Okay, that's what I was explaining there. Okay, I hope that made some sense. And then now let's go to number 4.
Hello.
Yeah,
Hello.
we are doing. Hello.
I was trying to ask, like, if you add a metal and the non-metal, at the end, you should end like IDE, right?
Yes, most of them.
Or most of them, not all.
Not all of them. There are exceptions, but most of them, they end in IDE.
Oh, all right. Thank you, then.
Okay. All right. Now, we've answered this one. We've answered this one. We've answered this one. We've answered this one. Okay. So now the remaining part is, let's change now these names that we've been given here. Okay, let's change them to formulas. So the first one that we've been given there is strontium fluoride. Okay. So here we'll make use of the periodic table. So we have strontium. Okay. The one with the mic on, please unmute yourself. I mean, mute yourself. We're getting a background from you. Okay, so we have this compound here, and then they want us to write its chemical formula. Okay, they want us to write its chemical formula. So you first identify the elements that you have. Okay, so this guy here is strontium, and it has the symbol SR like that. Okay, and then this one here is fluoride, so it means the symbol is just what? F. So before you combine these, okay, before you combine these, you have to know the valence of that element or the charge that it forms when it is an ion. Okay, who keeps unmuting themselves? Okay, so you have to know the charge that it forms. So this is strontium, and when you go on the periodic table, okay, you find it in group 2. So there is your strontium there. So this is group 2 here. And all these metals in group 2 have a +2 charge when they are in ionic form. And then fluoride is in group 7. Group 7 elements have a -1 charge. Okay, so after you know their charges when they are ions, that's when you can combine them. Okay, so this one here, we said it has a +2, and then this one here, it has a what? A -1. So it means when you combine these two, okay, to balance the charge so that it can be 0, it means we need 2 of these what? Fluoride. Okay, so the formula will be SR and then F with a 2 there. Why are we writing these 2 here? Because this fluorine has a -1. Okay, so -1 and another -1 makes -2. And then this -2 here is going to cancel out with this +2. Okay, so that's the first method you can use. Or you can say that since I have strontium here and then I have fluoride here, okay, I know that the valence of this guy, since it has a +2, I know its valence will be 2. And then this one, since it has a charge of 1, its valence will be 1. Okay, so we are going to do like a cross multiplication between these two elements. Okay, so this one for the fluorine will go to the strontium, and then these two for the strontium will go to the fluoride. So it will be SR1 and then F what? 2. But we don't show this one, so it means our formula will just be SRF2. So this here is the chemical formula for strontium what? Fluoride. Okay, so I hope it makes sense. Let's look at another one. Let's look at another one. So the next one is what we call as aluminium. Aluminium selenide. Okay, aluminium selenide. Okay, so first of all, you have to identify what elements you have. So the first element there that I can see is aluminium, which is just Al. Okay, and then this one here, the selenide, is what we call as selenium. Okay, so if you go on the periodic table, where is your Se? Okay, you see you find it in this group for oxygen. So selenium is somewhere here. Okay, so selenium is a non-metal, and then this aluminium here is a metal. Okay, so aluminium, we said it has a +3 charge, and then this selenium here, okay, since it's in group 6, okay, of the periodic table, it means its valence is 2, or it forms ions that have a -2 charge. Okay, so since we know that now, so this is selenium, which has the symbol Se. Okay, so this guy here, it has a valence of 3, and then this one here has a valence of what? 2. So we're just going to do like a cross multiplication here. Okay, so it means the aluminium gets the 2, and then the selenium gets the what? The 3. So when these two combine here, they'll form what we call as aluminium selenide. Okay, and we can see that the charges here will be balanced because for this aluminium, it has, remember, +3. So this +3 multiplied by 2, it will give you a +6 charge. Okay, and then when we go to the selenium, we said it has a -2. This -2 multiplied by 3 is going to give you -6. So this -6 and this +6, they cancel, giving this element a what? 0 overall charge. Okay, so that's what you should strive to achieve when you are writing the formulas or when you're naming. Make sure that the compound has a what? 0 charge. Okay, so if there are any questions, you can ask. If there are no questions, I'll go to the next one. Okay. All right, so the next one now, we are naming this guy. I mean, we are coming up with the chemical formula for this guy. This guy is called potassium nitride. Okay, so potassium nitride is just a combination of potassium and what? Nitrogen. So we need to know the valence of this one, or the charge that it forms when it becomes an ion. Even this one, the same. Okay, so when you go on the periodic table, where's the periodic table? We see that potassium is in group 1 here. Okay, so it has a +1 charge like that. And then where's the other guy? The other guy was nitrite. Okay, so you go on where you have your nitrogen here. So nitrogen, okay, is in group 5. So all the elements in this group 5 have a valence of 3. Or you can say that they form an ion with a -3 charge. Okay, so the valence of this nitrogen will be 3. The valence of this potassium will be 1. So you write the 1 under the potassium and then the 3 under the what? The nitrogen. And then you drew like a cross multiplication there. Okay, so what are you going to get here? You're going to get K, it gets this 3, so you have the 3 there, and then this N will get the 1, but we don't show the 1. So this here is the chemical formula for what? potassium nitride. Okay, I hope it's making sense. If it's not, please ask. Okay. And then let's look at the other one there, which was I've forgotten it. Okay, this one is magnesium phosphide. So how can we write the chemical symbol for this guy, magnesium phosphide? So let's have magnesium phosphide here. Okay, magnesium phosphide. So remember all these questions that we are doing right now, they are just a combination of the metal and the non-metal, right? Okay. All right, so this here is magnesium. Magnesium has the chemical symbol of M and then a small letter G. And then this is phosphide, so meaning it's coming from sulfur, right? Sulfur has a chemical symbol of P like that. Okay, and then from there, what do we need to do? We just have to find their valences, okay, or the charges that they form when they are ions. So according to the group number anyway, okay, so this magnesium, it's in group 2. So it has a valence of what? 2. And then this phosphorus, okay, this phosphorus is in group 5. So it has a valence of what? 3. Okay, so from this periodic table, guys, you can simply tell the valence of a certain compound. So let me guide you. Oh, well, now you can simply tell the valence, depending on the group in which it is, okay? All right, so the ones in group 1 have a valence of 1. The ones in group 2 have a valence of 2. And then these metals here that you have in between are what we call as transition metals. So these transition metals have multiple valences. Okay, they have multiple valences. So we jump this block of transition metals, we go to this group, which is group 3. So all the elements in this group 3 who have 3 as their what? Valence. Okay, and then group 4, it has 4. And then this group 5 here, it doesn't have a valence of 5, no. So when you reach group 5, you start subtracting from the 8 because we have 8 groups here, okay? So you say 8 minus 5. So it means all the elements in group 5 have a valence of 3. And then this is group 6 here. So you subtract from 8, 8 minus 3, all the elements in this group here have a valence of 2. Okay, and then this is group 7. So 8 minus 7, all the elements in this group have a valence of 1. And then this is group 8. So 8 minus 8, it means the valence for all these guys is just 0. So these are what we call as noble gases. So these gases, they do not react because they have a stable outer shell, okay? They don't need electrons, they don't lose or gain electrons. They are just stable like that. So they are unreactive. But these ones here, starting from this group here, all the way up to group 1, okay? They have unstable outer shells. So they need to gain electrons or lose electrons for them to be stable. So for the metals, which is group 1, group 2, and group 3, okay, they lose the electrons. So meaning these ones lose 1 electron, these ones 2, these ones 3, and then this group, this group, this group, they are all non-metals. Okay, so meaning they have to gain those 4 electrons. Okay, so that's how I knew this phosphorus here have a valence of 3. Okay, I thought it was important to share that. So this one here has a valence of 3, and then we do like a cross multiplication here. So what are we going to have? Mg will get the 3, and then the P will get the 2. So this formula here is the formula for magnesium phosphide, okay? Magnesium phosphide. Okay, so the questions can come in either direction. They can give you a formula, they tell you to name it, or they can give you a formula. Oh, what did I say? They can give you a formula, they tell you to name it, or they can give you a name, and then they ask you for the formula. Okay, so you have to know how to derive these formulas or how to get these names. Okay, so any questions there, guys? Any questions there before we do the ones that have radicals? Okay, all right. So we are done with those ionic compounds where I said we only have a metal, okay, and then plus a non-metal. Okay, so we've talked about how to name these and how to drive the name if you are given a what? A chemical formula. Okay, so now next up, we are doing ionic compound where we have a metal, okay, plus a radical. Okay, so a radical is just a special ion with a specific charge. Okay, so maybe it's important for me to mention some of these radicals. Okay, so we have this radical. This radical is called, okay, a sulfate. This is called a sulfate, and it has a charge. This should be 2 minus. It has a charge of -2. Okay, and then we also have SO3 minus. This here is called a sulfite. Okay, so notice the difference. If you have 4 here, okay, if you have 4 there, this should be 2 minus. Why am I writing? Okay, so if you have 4 here, this should be sulfate. If you have 3 there, it is what? Sulfite. And then it has a charge of -2. Okay, so I'm just listing out some of the common radicals. And then let's look at this other radical where I have MnO4 and then -1 as a charge. So this is called the permanganate. I know this name is famous. Okay, so know it by heart. So permanganate is just this radical here. So it has a charge of -1. And then what else? What else? Okay, I can have what I call as a nitrite. Okay, so nitrite. So this nitrite is given by this formula. Okay, we have NO2 and then the -1. So it means it has a charge of -1, right? Okay, so you should know some of these. Just master them. As you learn your chemistry, they will be in your head. Okay, another important one is this one. Cr2, and then we have O7 like that, and then we have 2 minus as the charge. So this one here is what we call as dichromate. Okay, so this dichromate here, it has a charge of -2. So it's a very common radical that you're going to experience or face or come across in your chemistry. Okay, right, and then I think the other one, let me say the carbonate. So the carbonate, I'm sure you've seen it. So this is the carbonate and then 2 minus. So this is the carbonate, okay? And then it has a charge of 2 minus. Okay, what maybe the cyanide. The cyanide is Cn minus. So the name is cyanide ion, or radical, it has a -1. Okay, so in case the class cuts, just join in using the same link. Okay, and then we have the hydroxide. Okay, the hydroxide is just this guy here. Okay, its name is the hydroxide, and then it has a -1 charge like that. So hydroxide. Okay, so these are some of the common radicals that metals can combine with, okay, to form compounds.